So welcome to the second lecture for this topic, where we're going to dive a little bit deeper into different parts of R. So we're going to get started first by looking at sequences and subscripting, sort of using vectors in R more like arrays that you might be used to from other programming languages. So here's an example where we create a single variable, first of all, with an initial value of 25, and then to create an actual vector, all you have to say is, lower bound colon upper bound. So 1 colon 10 gives you a sequence of values from 1 to 10. 5 colon 12 would give you a sequence of values from 5 to 12. You can also go backwards from 3 to minus 3. So 3 colon minus 3 would give you a sequence from positive 3 down to minus 3. And of course, 0 is one of the values in that sequence. You can even go as far as saying 2 times 1 colon 5, which give you values from 1 through 5 doubled. So 2, 4, 6, 8, and 10. Same, by the way, as saying 2 times, in parentheses open, 1 colon 5. But often the better way of generating a sequence is use a sequence function. It's not really any different, other than it allows you to generate more elaborate sequences. So here's an example for, in the first line here, that says sequence from equal 5 to equal 15 by equal 3. So there's sort of 3 parts to sequence. The lower bound from where you start the sequencing, to the upper bound, and then by, which is sort of the stepping of how many, by what values you go. So 5 to 15 by steps of 3. So it's 5, 8, 11, and 14. You're not taking the next one here, which would be 17, because it would exceed the upper bound. So you don't necessarily get the upper bound, in this case 15, because you're stepping by 3. Another example is sequence from equal 1 to equal 10, length equals 6. So that gives you exactly a set of numbers from 1 to 10 that is exactly 6 numbers. So essentially what you're doing is you're taking 1 through 10 divided by 6, and then use that fraction and add it to each one of the numbers starting at 1 all the way up to 10. This is often very useful for doing binning when you do histograms or other type of frequency plots. Another example for sequence is from equal 100, length equal 4 by equal minus 2.5. So there's no real upper bound. You basically keep on going for as many as you have in your length. So length says how many elements you want in your sequence. So in this case, you will have 4 in your sequence. And by equal minus 2.5. So that's a stepping, which means you actually start at 100 and you go down because you have a stepping that's a negative number. And then to assign sequences to variables, you can assign them. Here's actually an interesting example where we say x gets the sequence from 10 to 20. So you actually have 10 numbers, 10, 11, 12, 13, 14, up to 20 in x. And then we have sequence from equal 50 to equal 52 along x. So that basically means you say, well, I'm going to start at lower bound 50. I'm going to the upper bound 52. And I want you to go ahead and create as many values as there are in x, which means it's kind of like the second example here. This one right here, where you took a length equals 6, which basically means you somehow subdivided the interval. So there you do a very similar thing because you are subdividing, but instead of subdividing, you are subdividing along a sequence. So this along part right here, this part right here, basically determines what the interval is. So this corresponds to 10 to 20. So there's basically 10 values in here, and that basically means that you're going to go ahead and space it from 1 through 10 different numbers, and that means you're jumping along in point 2, because that is from 50 to 52 is 2 units divided by 10, so it gives you 0.2. So that's why the stepping goes from 50.0 to 50.2, 50.4, and so on. Now, once you have your data in arrays, or to be more precise, vectors, you can actually index the sequences like you would do a typical variable in a normal programming language. The operator for that is the subscripting operator. It's this one right here. Now, it turns out subscripting in R is a lot more flexible than many other programming languages, where you just simply have indexing from some lower bound to some upper bound as whole numbers. So here's a very simple example. x sub 3 gives you the third element in the vector x, which from the previous example you see it contains a 12. But you can also use a negative index, which actually says, I want you to extract everything but the third element. Take out the third element. The minus basically means take it out. So that means the vector now contains everything but the third element. So you notice right here that 12 is missing because that's the third index, if you the third element, if you index from, or if you have a sequence that goes from 10 to 20. So again, here's the sequence x from 10 through 20. I want to retrieve the fifth element and the seventh element. Well, you can't really subscript with 2. You can't really say, x 5 comma 7. That means something very different. But you can use as a subscript index a sequence. So for example, if you say, I'm going to concatenate 5 and 7 into a single sequence, into a single vector, and then you can use the vector as a subset, which basically says, I want x sub 5 and x sub 7. And that gives you, in this particular case, the fifth element. That's 1, 2, 3, 4, 5, 6, 7. So you get the fifth element and you get the seventh element, 14 and 16. If you use negative numbers, like you have it in an example right here, that's going to give you the vector with everything but the third, fifth, and ninth element. Can also apply a filter to subscripts. Again, this is very unusual but very common to R. So what we're going to do right here is we're going to extract all the elements whose value is greater than 14. So which happens in this case to also be elements, 15 through 16, 15 through 20. But this is not really the indices 14, 15, 16, but it's really the elements whose value exceeds 14. So it's basically a filter that you apply to this. So we're going to leave it at this point in time. What we've seen now is we've seen some subscripting, and we've seen how we can apply subscripting to in a more sophisticated manner, access sequences. We also saw the sequence function that shows us how to access and how to create, not how to create, how to access, but how to create sequences of numbers. What we're going to do next is we're going to look at another data structure which allows indexed accessing called data frames.